Okay, on this question, to find the resistance, the key equation I'm using is the one with resistance and power. So I've got resistance and power and voltage, because what I know my voltage, and my power, and I know my voltage. The one that has power and voltage and resistance in it is this equation. So I'm going to use for question A, P equals V squared over R, and you're going to solve for R. You know voltage, you know power, you can do the math. The B question is a little trickier question, because once you know the resistance, you need to first find the energy. So the first thing is, because as I've said in this thing right here, is the energy equals mc delta T, and you know the what's called the C, the specific heat. So you're going to have to use the equation P is equal to energy over time. Right, that's this equation right here. And then you're going to solve for the energy, because they gave you some kind of a time frame. Oh no, you're solving for time. So how did I do this? I said, oh, I solved for energy using this equation, right? Yeah, that's what I did. So I did the mass. We knew the mass was 400 grams, which would be 0.4 kilograms, times the C, times the change in temperature. The change in temperature, it went from 20-some degrees, 23 degrees, to 100, so about 70, 67 maybe, or 77, something like that. I can get 77 degrees. And that gave me the E. And then I knew the power as 400 watts. So if this is 400, I can then solve for the time. I did, by the way, convert to minutes, because of course you're going to get the answer in seconds, but it's quite a few seconds, so you may want to divide by 60 to get to minutes.